Thanks for having me, Rex and Tom. Tom, you had mentioned I'm one of the new people. um, so to give you a little context, Tom Mackie with Wolpert Incorporated. Many of you don't know who I am, and many of you don't know who Wolpert is. We are an architectural engineering and geospatial firm. We have been a standalone entity for over 115 years. We're established in 1911 here in Dayton, Ohio. So uh, we've been around for a long time, and particularly in the aviation space, we are noted as a airport consultant, primarily as our background. There's a heavy geospatial spin to our company, and so my background and why I'm even sitting at the table here with you all, the virtual table, as was mentioned with you all, is because of a lot of our background in the aviation space when it comes to airport safety, airport safety critical data, geospatial solutions, particularly supporting instrument approaches, low altitude routing, and all kinds of other activities beyond just your more traditional airport consulting. And so one of the areas that we have expanded into, and where a lot of our backgrounds are going to provide a lot of value, is in this space of vertiports. So many of you don't know who I am, so I've been learning a lot over the last 6 to 8 months as I've heavily got engaged in this particular group. But where we've been really established, as I mentioned, is in a lot of this emerging area of UAS, UAM, and extensible into vertiports. And I guess, Rex, you have control. Go ahead and let you fire the next slide. So let's get in. I wanted to provide everybody kind of a brief update, as Rex had mentioned. For many of you, maybe this is not new. This is kind of a leftover topic, I would say, kind of segueing from a lot of the topics discussed yesterday. And so we'll go through a little bit of research that's taking place right now at the FAA and give you all some insight into what we're all up to. So what's kind of led us into this topic? Obviously, it's the emergence of this eVTOL UAM industry. I think that's pretty much self-explanatory. We have disruptive technology. It's not the first, right? UAS, small UAS in particular, really has gotten a lot of attention. But more importantly, even a larger impact into all of the aviation industry, in particular into the helicopter operational world, is the emergence of this eVTOL and UAM industry. So what's the problem, and what's leading us to have to address some certain things is the key components in order for the UAM and eVTOL vehicles to be able to integrate. We need to have a lot of more information and a lot of development in terms of standards and understanding and protocols as it relates to vehicles and air traffic management. And as this group is probably mostly interested in, based on the topic of the group, is the infrastructure piece. So there's a large void in terms of standards and policy and specifications. So we'll get into a few more details here. So where it's led us to today is advanced research through the Aviation Research Division at ATRD. They're at the Tech Center, particularly out of the Safety R&D section. Go ahead, next slide. And how they're approaching this was through a research project, particularly or specifically focused on vertiport design for eVTOLs. What's up there is a summary of direct out of communications from the FAA in terms of what they're trying to achieve with this research. So you can see it's particularly looking at, what is going to be needed and what recommendations need to be made for a standardized design, more importantly, standardized design criteria for your VTOL aircraft. It's slicing off and eliminating small UAS and focused on that larger aircraft, the 7,000 pounds, nine plus passengers or more. So the idea is to start to develop a number of recommendations at the end of the day, which do result into advisory circular standards At least that's the current vision that is then going to be able to be applied as the UAM industry advances. Now, key components of things we're looking at. Now, this is not all encompassing, but this is on the right-hand side of the slide. These are the key aspects of the study that's being completed, right? We need to be looking at the vehicle sizes to where we can then start to look at and determine things such as geometry, and all of the other requirements you will find in your existing advisory circular standards with surface parameters and markings and safety signage, and an area that is also new to the aviation industry when it comes to especially vertical operations is the electrification of these vehicles. That's a whole new ball game, and there's a whole lot of, as many of you may know, there's a whole lot of gaps, if you will, in what's understood and how to deal with the electrification propulsion versus traditional. Go ahead, next slide. So what is being accomplished, right? What is our overall mission and the goal of this study? It's really to work with the FAA in particular, develop design standards that can then, as I mentioned, roll over and be utilized through the urban air mobility, the UAM industry, so there's a commonality and an understanding of the facilities and what are required. Key focus areas as we enter into this research is to maintain safety, right? That's probably number one. Everything we're talking about is functional in terms of the facilities, but it's all got to be maintaining that level of operational safety, not just for the aircraft, not just for the passengers, but also for the community around it. As you can imagine, incredible volume of collaboration across industry. Industry is big. So it's not just one area, say academia, or one area, say working with the FAA or NASA. There's a whole industry that's evolving with a lot of different stakeholders. So it's very important that piece is riddled throughout the process. Something else we identify that is really important is whatever we make recommendations on at the end of the day, when it comes to these criteria, they've got to be resilient. We've got to be able to establish standards, much like the FAA has done a great job of in their current advisory circular standards. These things can persist for years. They can apply in many different times in many different situations. So again, having an ability for, as the industry emerges, allow for emerging design requirements. And then finally, something that's implementable, something that can be implemented that is not ungodly in terms of cost and challenge, but something that can actually roll over, connect with other advisory circulars, or more importantly, just other criteria, and be able to integrate nicely. As you can see, we have a small team that is focused on this. Ourselves at Wolpert, Rex and 5 Alpha, you're a little bit everywhere, but incredibly important. And then we have a really unique design consultant based out of New York, and DY Consultants, which has done a fair amount of work with Heliport designs in the New York City area. Go ahead. Next slide, Rex. So where to start from? We're not really starting from scratch. There is, obviously, many of you are aware of the Heliport standards, right? The 5390-2C, but there's past history that the FAA has approached this VTOL industry. So back in the 70s, I don't have personal experience here, so I apologize. But back in the 70s, tilt rotor and tilt wing aircraft were starting to emerge, and it really became hyped up, and everybody wanted there's a lot of energy around this idea of being able to fly from building to building or house to house, right? Those early concepts never really gravitated, never really took hold. So the industry kind of fizzled out. And due to that, there was a cancellation in 1991 by the FAA of that advisory circular. Again, just because of limited interest. And so we're, as I mentioned, not really starting from scratch, but there isn't a one-to-one comparison between that the 5390-3, the Vertiport design standard, and where we are today. So just a reminder, as we look at this, the way that we're looking at this industry is VTOL vehicles are not helicopters, they're not airplanes, they're somewhere in between. And so there's just a big a void in this airspace, so to speak. Go ahead, next slide. So how are we tackling this monster? First of all, this will be conducted over approximately a 36-month period. Again, that's what the original prescribed approach was by our team. As you can see, going from the top left across around to the right, underneath the bottom, back to the left is our general overall approach. Go ahead and flip the button. Something should happen if you flip the button. So where we are right now is right there at the very beginning. So I should have started off by saying if anybody came into this call expecting all kinds of great intel and information about what to do in terms of designing and building vertiports, ain't going to happen today. So we're really early into the process, and we're learning a lot. So initially, we're going through this process of a lot of literature review and intel gathering. We've got to start there. Essentially, we've gone through somewhere over 100 different documents from a number of different areas in the industry, from government, from private industry, from academia, and in international standards that exist. So we've been pouring through a lot of those. We've whittled it down to close to a manageable 70 documents, if you will, that are going to need to be scrubbed for a lot of existing information to help produce a final product. As we go through that, we will do a series of interactions with, you see an acronym IAB. It's really kind of morphed from that, but what we're identifying is that industry engagement. The FAA in particular will probably be leading this effort as we get closer to where we have to have more engagement, but the industry is so large, these are going to be critical components as we march through this process. After we get through the lit review and we devise some standards, then the fun will start to begin. We will be conducting some conceptual testing and modeling through using TAM software or other modeling software like that, where we'll put some conceptual designs into a system. We will run a series of different scenarios, lots of different atmospheric and environmental situations to try to start to flush out, do these standards work when we apply what we know in terms of the VTOL equipment, or vehicles, I'm sorry. And then we'll move into actual full-fledged operational testing. There's notions of building a vertiport someplace as a proving ground to really try to produce some real testing and bring eVTOL equipment to it of all different shapes and sizes, and try to conduct some testing there. And then the result will be a series of design standards and recommendations that will result in an advisory circular of some sort. But again, 36 months from now, so we got a little bit of work to do, plus there's a whole lot more visibility that'll come. Go ahead, Rex, next slide. So what we have done, and here's a little bit of detail in terms of some accomplishments we have completed to date. As I mentioned, we've been pouring through a number of documents. We've tried to whittle out, for those of you that have gone through a number of research projects, everything you pull off the shelf isn't necessarily valuable or applicable. And so the team and Rex would be able to definitely agree and confirm this, but it's taken quite a bit of team of researchers to be able to pour through a lot of documentation coming from a lot of different places. After we get through that, the key part will be that gap analysis. Then we'll be able to start to identify where do we have gaps between existing standards, whether they're heliport standards, airport standards, ICAO, other areas of specifications that have been defined, and what we're seeing coming in from the eVTOL industry, and where those current gaps exist. We'll identify those, we'll try to incorporate those to where we can march into that initial draft set of standards, flush them out with some testing, and then move on. Okay, go ahead, next slide, please. So connected to this is something we wanted to bring up. It's not exactly the same, but it's a piece that I felt very important that kind of ties some of these efforts together. There is a tangential effort going on right now through the Office of Airports at the FAA to develop heliport geospatial data standards. Now, fortunately for me, for the last 15 years, I have been living and breathing what you see there in the second bullet, the 150-5300-18 Bravo. It is an airport-driven, airport facility-focused set of standards. But the intent, where we started creating these circular, there's a couple others that go with it, but this particular circular was to drive in a number of things: improve safety at airports, particularly common and standardized safety critical data. So runways, taxiways, obstacles, nav aids, lighting, things that are absolutely critical and important for the design of procedures, but also to aid the pilot. And so we started this process a number of years ago for airports. And as you saw in presentations yesterday, there is a very substantial issue with heliport data. We can slice it and dice it any way we want. We can use Google. We can just turn a blind eye. We can go through an incredibly robust data development process. We haven't figured out the best answer, but there is a problem. And in order to advance the eVTOL and UAM industries, there's got to be some work done in this space to start to drive it. So what we're doing is going through the process of developing, a set of standardized. Let's just be honest, it's GIS data, right? How do we develop a standardized GIS schema that is not only going to come into the FAA and be housed at the FAA as an authoritative source, but more importantly, how reliable? It needs to be reliable, verifiable, and we're following the same philosophies as we've gone through with the airport's GIS databases. And at the end of our work here, we will be developing an engineering brief that will be applicable when applying the heliport data standard, heliport design standards. It'll also be applicable for instrument approach procedures. Go ahead, next slide. So here's just kind of a glimpse into what I just mentioned. This is a table out of the 5390 draft, 5390 2D. And so I think you saw this yesterday potentially, but again, what you see is that line for survey required. What we're addressing is that particular line about 3/4 of the way down in that table. And as I briefly mentioned before, what we're getting at is the delivery of quality survey data to the FAA. Not been required before. However, as we mentioned before, there is precedent for a robust, standardized, and quality database for safety critical applications. So delivering the survey data to the FAA. This then establishes that authoritative source that the FAA can use, operators can use, third-party developers can use. Everybody is then working off of the same sheet of music when it comes to some of the most critical foundational piece for safety, which is knowledge of that facility. The final piece of that, and why I mentioned this is really critically important, is there are issues to address now in the helicopter space, or there's assistance. Let's just be honest. Maybe it's not as much of an issue as much as it's improvements to be made in helicopter low altitude operations and approach departure procedures, but it's all foundational for the integration of what we're looking at with all these emerging technologies coming into that low altitude space. And most importantly, I think, is again, coming into some of this industry new is that ability to protect the airspace around heliports. We see it a lot in airports. There's a lot of mechanisms for that protection. And there's an opportunity here through this process to be able for the FAA to be more direct in terms of protecting airspace for heliports. And go ahead, next slide, which I think should be the last one. And that's about it. Wanted to provide everybody a quick overview of what we're doing and where we're heading. Hopefully it didn't put anyone to sleep or completely confuse anyone. So thanks for having me, Rex and Tom.
No, and thanks, Tom, for the information. It's definitely very good to look at what's coming down the future and try to get ahead of it from a safety standpoint. Yeah, I would point out the work that Tom's been dealing with the GIS piece. This group, the U.S. Helicopter Safety Team and the Infrastructure Working Group, has been pushing pretty hard in some of those spaces for several years. And due to some of the work that we've done with this group, that is what the FAA is now tackling with Tom's company through the FAA Reauthorization Act and Heliport accuracy for the airport master record. So it is a slow process. Nothing happens overnight, but we are making progress. And that's, I think, the benefit. Any questions from the group? I don't have anything in the chat right now on anything that Tom had just discussed for either the urban air mobility eVTOL world and vertiports or on the GIS data. Anybody there that wants to come off mute, please feel free.
Yeah, Rex, just Cliff here. I just wanted to just make a quick comment to Tom. I thought it was a really good briefing. I always learn something listening to you guys on this stuff, and I think it was timely. And I think it really speaks to, you said it as well, but I talked about it yesterday. Really good GIS data and fixing some of the things with the 5010. It's a process, as we all know, but it's really important for this. I think I had one just minor question, Tom. If you go back to that slide that had the layout of it was your table and it had the different standards and everything. Question, this one. I may have missed it on there. Is this what exists currently, or is this kind of what you guys are proposing with sort of like revised standards? That wasn't really clear.
Oh, sure.
But I may have missed it.
Sure. No, we just to be clear, Wolpert and our collaboration with airports and flight safety, we did not develop this. This came out of a draft, the draft advisory circular 5390-2D. So this is what is in the current draft document. So
okay,
this was
that's what
not
I thought,
created
but I just wanted to make sure. So,
sure.
Okay.
Let me just add something there too. Our effort in this geospatial data standard world is not to develop policy. All right, that is not our place. We are providing the guidance for the technical components of the data, the validation, the best practices, and to help develop. It was mentioned yesterday that surveys can become very expensive. We don't want that to happen. So we're in place to help govern that, to try to make these digestible in terms of the data components that would need to be developed. So to kind of feeding off of what you just asked there, Cliff, yet this was not developed by our team, rather this is being utilized straight out of the draft standards.
Okay. Any other questions? I saw a note there from our friend.
Yeah, I think I see Nolan.
Nolan Crawford, did you have a comment?
Hey, Cliff, the chart that's up right now was actually developed by the helicopter modernization team. It'll be part of the brief coming up in about just over an hour now. So Dante will go into this chart a little more in depth. The team did that with the collaborations with airports, and it's going to be put into the 2D. Whether this is the final form of it right here or not, just a little bit more time will tell on that. But Dante will explain this from the perceived VFR side on the right side, all the way over to a full-blown IFR heliport on the left side when we do our modernization brief.
Okay, thanks, Nolan. Yeah, I really like it. I think it's well done, so I'm looking forward to it.
All right, sir.
Nolan, I probably should have slapped a draft across the front of that because figured you guys would cover it next.
It's all good, sir.
Okay. Well, with that, I appreciate the brief on the Vertiport piece, Tom, and very interesting on the GIS piece as well. Look forward to more information. And if anybody has any questions, there's Mr. Mackey's email address and phone number. So again, these presentations and recordings will be available on the USHST website at a point in the future.